So this is another question from IIT JEE PYQ. The question is from the chapter friction. Here is the question. A block of mass 2 kg rests on the rough inclined plane making an angle 30 degree with the horizontal. The coefficient of static friction between the block and the plane is 0.7. The friction force on the block that we have to find here. Let me draw the diagram. This is an inclined plane and it is making an angle of 30 degree with the horizontal, and let us suppose this is a block of mass m on here. Okay, and the value of m is given as m is equal to 2 kg. We will substitute this value later. Okay, now what are the forces acting on this block is, one will be in downward direction, that is the gravitational pull due to the earth, that is mg. One will be the normal force due to the surface contact. And let us pause, let me draw this line. This angle will also be equal to 30 degree from the geometry. And the component of this mg along this line, that will be mg cos 30. mg cos 30. Okay. And the component of this mg along the line parallel to this inclined plane, that will be mg sin 30. mg sin 30. Okay. Also the block is having tendency to move downward towards this inclined plane, so there will be a frictional force acting on this block, that will be let us suppose it is F. So here for this block to be remain in the equilibrium position, let me consider the equilibrium position perpendicular to this plane. Okay, so I will be writing the forces that are perpendicular to this plane. That means normal force will be balancing this mg cos 30, that is equal to the value of normal we are getting here, that is what, mg cos 30. The value of cos 30 is root 3 by 2. Sorry, the value of cos 30 is root 3 by 2 only. Okay, and the value of now we will substitute all these values. The value is 2, the mass m is equal to 2 kg multiply g we have to take here 9.8, that is 9.8 multiply root 3 by 2. Okay, so here 2 will be cancelled out, so value of normal is, that is root 3 multiply 9.8 Newton. Okay, so this is the value of normal. So what can be the maximum value of this static friction? So maximum value of this static friction, that maximum value of static friction, that Fs will be equal to mu times of this normal, and here the value of mu is given as 0.7. so this Fs will be equal to value of mu is 0.7 multiply this normal force is what, root 3 multiply 9.8 Newton. Okay, so this is the value of static force that can be provided to keep this block stationary. Okay, to prevent the relative motion between this block and the inclined plane. Now I will calculate the value of mg sin 30, that is acting in downward direction. So mg sin 30 will be equal to m, the value of m is 2 multiply g is what, 9.8 multiply this sin 30 is what, 1 by 2. Okay, so here we are getting this mg sin 30 is equal to 9.8 Newton. So as we can see, this mg sin 30 here, mg sin 30 is less than this static friction. Okay, so to keep this block stationary, friction force will be acting in backward direction, and the value of friction force will be less than or equal to this static friction. Okay, सो ब्लॉक को रेस्ट पे रखने के लिए या तो फ्रिक्शन फोर्स की वैल्यू स्टैटिक फ्रिक्शन के बराबर हो या फिर उससे कम हो, जितना रिक्वायरमेंट होगा उतना ही स्टैटिक फ्रिक्शन लगेगा। ओके, सो यहाँ पे ब्लॉक को स्टेशनरी रखने के लिए डाउनवर्ड जो फोर्स लग रहा है उसकी वैल्यू है 9.8 न्यूटन। सो उसको स्टेशनरी रखने के लिए जो फ्रिक्शन फोर्स की वैल्यू लगेगी वो लगेगी F इज इक्वल टू 9.8 न्यूटन ओनली। ओके, इससे ज़्यादा फोर्स की रिक्वायरमेंट नहीं है, क्योंकि फ्रिक्शन फोर्स ऑलवेज प्रिवेंट्स द रिलेटिव मोशन बिटवीन द टू बॉडीज। So that's why our answer will be equal to 9.8 Newton only. That is option A is correct here.